Okay, so I'll be doing 2019's test one. So let's pretend that I read this whole paragraph now. So we'll just pretend that I read it, and now this is the data that we are given. So they are saying that suppose sample values of earth density obtained from the experiment are summarized using a stemming leaf displayed below. So we can see that we've got a stemming leaf. So the first thing that you do when you have a stemming leaf, you check your key, right? You check your key, and then after that you can take your calculator and start inputting the data, as I told you in other videos where we're doing descriptive data. After that, you can proceed to answering your questions. So the sample, mean and standard deviation of the data in problem A are. So the answer that I circled is the correct answer in that case. So I'll show you how we obtained it. Okay guys, so this is my calculator. So the first thing that you do, you're going to press this button here, then you're going to press number 3, then you're going to press number 1, then you will insert all the data values that are given to you. Okay, so I've inserted all my data. You can exit there. So to find the mean, you're going to say shift 1, choose option 4, then number 2. That's your mean, right? And then for the standard deviation, now you're going to, so guys, in this case you are going to choose number 4. That's your standard deviation. So that's why we got that answer, guys. The sigma one applies when we are talking about populations and stuff. We'll do that later, right? So now we are dealing with samples. Just use number 4 to get correct answers. This question was like find the median and the mode. So you can find the median using your calculator, and the mode, you look at the most occurring number. So from the stemming leaf you will determine the most occurring number. So to obtain the lower and upper quartile values, guys, you know that you use the pseudo rank to get the answer. After explaining this, I'll show you a picture of the calculations that I did. And then they said which of the following is true with regards to the box and whisker plot of the data. So I'm going to also show you the box and whisker. So guys, for these things, guys, we have videos where we're doing descriptive data, showing you how to get these things. So this is just a revision. If you don't know, if you are lost right now, please go and check those videos. They might help you, or refer to your slides, the textbook, or any other material that you have, right? Okay, so this is the solution for Q1, the lower quartile, for Q3, the upper quartile. So this is how we draw the box and whisker, and you know how to check for mild outliers or extreme outliers. You know how to draw your box and whisker. If you don't, please do check out our video on how to draw a box and whisker and determine your outliers, right? So okay guys, so unfortunately we can't do problem B because we only have this one, and this one we were told that we should cancel it because the question was wrong or some parts were missing. So we can't find the paper, So we apologize for that, but we'll continue and do the other questions. It's not a train smash. Okay, this is problem C. So it was telling us that each of the 12 companies that manufacture soap has been submitted 1 bar of soap for inspection. Of the 12 manufacturers, 3 are big manufacturing companies that have been in business for well over 100 years. 4 medium-sized companies that have been in business for between 40 and 100 years, while 5 of the companies are small enterprises that have been in business for at most 40 years. A technician has the task of randomly inspecting the 12 bars of soap. So question 6 says the probability that among the first 6 bars inspected there are 2 bars from small enterprises that have been in business for at most 40 years. So I believe anyone can do this now. If not, you just have to go back to your lecture slides, your textbook. Just make sure you brush up your counting method and your understanding of probability. Okay, this is how we obtained the answer. So again, okay guys, so you will see that I didn't do question 7, and the reason I didn't do question 7 is that last year we wrote the test and the options from A, B, and C and D, the correct answer wasn't D, right? So what happened is that the lecturer awarded everyone for question 7, but also you need to be sure of what you are doing. So there are students who just chose any random answer and others just left the question, or they just wrote that no correct answer. So the question was 4 marks, so all the students were awarded 4 marks for that, and the ones who didn't answer that question or who wrote that there was no correct option, they also got an extra 4 marks for that. So be sure that you understand what you're doing and you are not just doing those things to get answers, but and you'll be able to see when there's no correct answer or when the answer or the solution that you are given is wrong. So this is the section B of the question paper. So I hate doing probability examples because we are different. We read the problem statement differently and understand it differently. Then we apply different methods, right? But at the end we get the same answers. So I don't like doing the examples because I don't want to confuse you guys. Okay, if the method that I'm using is different from the one you are using, it's okay. Continue using the method that you are using as long as you get the correct answer and you understand it and it works for you. Don't be confused or want to change. Just stick to your method and get the correct things. So question 8 says that 6 of the 20 nails contained in a box are defective. Whilst working on a carpentry job, Nehemiah randomly draws 5 nails, one after another, from the box. What is the probability that out of 5 nails that he draws, at most 2 are defective. So okay, they gave you a hint that you can use the multiplication theorem or whatever. So I'll show you how I did this question. So I used two methods to solve this question. So first, I used the multiplication theorem, and the second time I was just using basic counting method principles. So here we were using the multiplication theorem. So we know that Nehemiah will randomly select 5, right? 5 nails, and now we want to determine the probability that at most 2 are defective. So defective, sorry, I apologize for that. So we know that here we have 0 nails that are defective, and here are just the probabilities. So we know that we have 14 nails that are not defective, so we're going to say 14 divided by 20, because inside the bowl or box that he's choosing from we have 20 nails and 14 of them are not defective, so we'll say 14 over 20. Now that because he's taking out the one nail from this selection, we are going to say 13 divided by 19, because now of the 19 nails that are remaining, 13 of them are not defective. So we'll do so for all of them. This is the case where we have only one defective nail, and then this is the case where we have 2 defective nails. So because we know that we have 6 defective nails, so we are going to say 6 divided by 20. So of the 20 nails that are in the box, 6 of them are defective. After taking one out, we're gonna be left with 5 defective, and then the rest will be the nails that are not defective, right? I hope you understand. So, or you can just use counting method principle depending on how you understood the question. So this is our sample space, that from 20 nails we are going to choose 5. So here we are saying that because we know that we have 6 defective, we're going to choose 2 from them, and then from the 14 that are not defective, we're going to take 3. And this is the case where we have 2, where we have 1, then when we have 0 defective, we get the same answers. So just use any method that you feel like, any method that works for you, right? So question 9 says, suppose that the probability that a left-hand truck traveling on a stretch of a highway is defective is 1 over 3, and the probability that a right-hand truck traveling on the same stretch is defective is 1 over 6. 20% of trucks traveling on this stretch of the highway are left-hand driven. Determine the probability that a truck traveling on the stretch of the highway is defective. So reading this question, you can see that this is conditional probability, because they are telling you that the probability that a left-hand truck is defective equals to that. So it is the probability of D, given that the truck is left-hand, right? So let me show you how we do that one. So you can draw a tree diagram for what you have. So this is the 20% that they told us, that 20% of the trucks are left hand driven, and this is the probability that okay, the truck is not left hand driven, it's right, so it's going to be 100% minus that. So you can either use decimals or percentage, it doesn't matter, depends on what you prefer. So this is the probability that the truck is deflective given that it is left hand driven, and then there's a probability that the truck is not defective given that it is left hand driven. So these are the probabilities that we're given, and they want us to determine the probability that a truck will be defective. So using the law of totality, we know that we are going to say it's P D given L times PL and PD given R times PR. Then we will get that our answer is this, right? So question 10 says, suppose that 80% of the cars reported stolen in South Africa are subsequently recovered. Of the cars that are recovered, 85% are fitted with a mobile tracker, whereas 90% of the cars not recovered are not fitted with trackers, right? So they told us that the probability of recovered cars is 80%, right? So let me show you the solution. Guys, we saw that the question 10 is also a conditional probability question. So if you don't prefer drawing the diagram, it's fine. You don't have to draw the tree diagram all the time, it's fine, depends on what you prefer. So if you don't want to draw that diagram there, you can simply write all the probabilities that are given to you and determine the others. It's the same as using the tree, but here you're just writing them. So they said that we should find the probability. Okay, I didn't read the whole question, but okay, this answer, they wanted us to find the probability that they told us that our neighbors, the statement told us that okay, so this is the solution. So this is the solution, guys. The probability that it will not be recovered given that it has a tracker equals to this. We are using the conditional, we are using Bayes' theorem, and this is what we get when we solve the question. Okay, so the question that I didn't read is this one. It was like, suppose your neighbor who has just relocated from Switzerland has reported that his car, which is fitted with a mobile tracker, has just been stolen. What is the probability that it will not be recovered? So the solution I just showed you was answering this. Apologies for not reading the question first. So question 11 says, a machine has 4 electrical components, U, V, W, and X. The probabilities of the components U, V, W, and X being faulty at the time a technician turns the machine on are that respectively. What is the probability? Then we have A, B, and C. So I'll be showing you how to answer that question, guys. Okay, we have component UV, machine UV, W, and X, and these are the probabilities that they are faulty. So they said A wanted the probability that none of them are faulty. So because these are the probabilities that the components are faulty, we know that to find the probabilities of them not being faulty, it's going to be 1 minus the probability of being faulty. So that's why you see a 0.9 here, a 0.8, 0.7 and a 0.8 like that. So this is our solution. And then they were like, the probability that only one component is faulty. So guys, when I do those questions, I always do them manually. I don't know if there's a formula that you can use, especially when the probabilities are different. I don't know if there's a formula that you can just use without doing this manually. So this one, it's when U is faulty plus when V is faulty plus when W is faulty plus when X is faulty. So you saw that V and X have the same probabilities, so that's why I always say times 2 here, because I'll have this term repeating itself, right? Then you will get those. So just do it manually, that if U is the component that is faulty, it means the others will be working. So you will take the probability of U being faulty is 0.1, and the others you'll use the probability where they are working, right? So it says also the probability that 2 components are faulty. Also guys, the girl did it manually. So doing it manually, guys, that's the only method I know. So you need to make sure that you do, or you include all the conditions. So here there's a condition where these two are not working, these two, that, and then these two, and then these two, then these two. So to make sure if you have the correct number of equations, so you know that we have 4 components. So if we have 4 components and we want the probability that 2 of them are faulty, we will say 4 choose 2, right? Then we will have 6, meaning that the number of conditions or equations that you must have here is 6. So you see we have 2 plus 1 is 3, plus this 2 is 5, plus this 1 is 1. So that's how you can make sure if you've included all the cases, by doing that and by just manually determining your things. That's how I do questions like this when the probabilities are not the same. But I found a quiz from 2018, not 2020, sorry. So there we had 6 components, but the nice thing is that they all had the same probability, right? They all had the same probability. So you can see that here, because they have the same probability, we somehow use the binomial distribution. So because we haven't done random distribution yet in this channel, I'll just explain it like this, but just bear in your mind that this is a binomial distribution, and you'll see it later. And so we want the probability. Okay, the question said in the quiz, that a particular system in a space vehicle has 6 components. Each component of the system operates independently of any other, and the probability of a component working is 0.8. To increase the reliability of the system, the 6 components are installed in such a way that the system will operate successfully if at least 3 of the components are working, what is the probability that the system will work? So we want the probability that at least 3 of the components are working. Right. So thus, because the probabilities are the same, and as I said, you can use the binomial theorem, which you just like, okay, of the 6 components, choose 3 that are working, and the probability of that is 0.8 times 0.2 to the power of 3, because now if 3 are working, it means the other 3 is not working. So if the probability of the components is the same, just use the binomial theorem, just use it like this. And if the probabilities are not the same, this is the only method that I know. So this was 2019's test 1. I've posted 2018's test 1 go Telegram, so you can go check it out there and practice. Also, I've also sent the 2015 test. You can just do it for practice, and for those who will watch this before their test, all the best, guys.